2-5, Part 2, Multiplicative Inverses of Matrices. We're going to look at the identity matrix. Here we have an example of a 2-by-2 identity matrix and a 3-by-3 identity matrix. Notice that there are 1s on the diagonals and 0s everywhere else. The identity matrix is to matrix multiplication as 1 is to regular multiplication. Remember that if we multiply a number times 1, it retains its identity. This is true when we multiply an identity matrix times another matrix, like this. It works the other way as well. If we've got a matrix times the identity matrix, we also get the original matrix. This is written symbolically as I, capital I, for the identity matrix, times capital A for the regular matrix, and that gives us matrix A. And likewise, matrix A times matrix I equals matrix A. So the identity matrix multiplied by any matrix lets the any matrix keep its identity. Inverse matrix. First we'll look at a 2-by-2. We've got matrix A here, and the elements are A, B, C, and D. The calculation for the inverse of A is as follows. Notice that the denominator of the fraction here is the determinant of the original matrix. So we could also write this as 1 over the determinant of the original matrix times this new matrix. The new matrix is created by taking the original matrix, switching A and D, and changing the signs of B and C. So make sure that you notice that B and C keep their original positions and just change signs, and it's only A and D that switch positions. And we multiply that new matrix, as I said before, times 1 over the determinant of the original matrix. So let's look at that with this example. The inverse of A will be 1 over the determinant of the original matrix, so 2 times negative 10 minus 4 times negative 4, and that will be multiplied by the new matrix, where we've switched the position of the 2 and the negative 10 and changed the signs of the 4 and the negative 4. Now we'll calculate. First we'll calculate that determinant, so we end up with 1 over negative 4, and we'll multiply that by each element. Remember, this is scalar multiplication, and the scalar in this case is negative 1/4. So when we do that, after simplifying, we'll end up with the matrix 5/2, 1, negative 1, negative 1/2. So what happens when we multiply a matrix by its inverse? Well, let's first consider what happens when we multiply a number by its inverse. So here we have 7 times 1 over 7. When we multiply 7 times 1 over 7, we get 1. We get the identity. So if we look at multiplying matrix A and matrix B, and we're told that they're inverses of each other, when we complete their multiplication, we end up with this solution. Notice that this is the identity matrix. So, when we multiply a matrix times its inverse, we get the identity matrix. Remember what we said before, the identity matrix times a matrix gives us that original matrix. So why do we need to know all of this? Well, to solve problems. So first let's consider a system of equations. And this is a 2-by-2 system, and we're going to write it or rewrite it as a matrix equation. And we're going to solve using inverses. So notice here that we'll rewrite the system as a matrix equation with a coefficient matrix times a variable matrix equal to an answer or solution or constant matrix. If the determinant of the coefficient matrix equals 0, then the inverse does not exist and there's no solution to our system. Because remember, when we're calculating the inverse, part of that calculation is 1 over the determinant. So, if the determinant is 0, we're dividing by 0, which can't be done. And so this system would not have a solution. So let's consider our system, or our matrix equation we've created. And we're going to try to solve this for x and y using inverses. So first I'm going to let A be the coefficient matrix. And I'm going to multiply both sides of our equation by the inverse of A, just like undoing when we're solving a two-step equation in regular algebra. So let's first consider it with symbols. Here I've got A times xy is equal to 11/8. I'm going to multiply both sides of my equation by the inverse of A. Note that I've put the inverse matrix to the left of all of my items on both sides of my equation. The result on the left side of my equation will simply be my xy matrix. Because remember, if I multiply a matrix times its inverse, I get the identity matrix. When I multiply the identity matrix times xy, I'm left with xy. So that takes care of the left-hand side. On the right-hand side, we're left with the inverse of A times our solution or answer matrix. So let's look at it with the numbers. First, I'm going to calculate what is the inverse of matrix A. That calculation results in -1, 2, 2, -3. So I'll multiply both sides of my matrix equation by that new matrix, or the inverse matrix. The result on the left gives me the identity matrix times xy. The result on the right gives me the matrix 5, -2. When I multiply the identity matrix times xy, we get xy, and that equals 5, -2. So the solution to this system is x equals 5 and y equals -2, or the ordered pair 5, -2. Solving systems of 3 equations in 3 variables can also be done, and we're going to use the graphing calculator to do this. So here let's consider this 3x3 system, and we're going to rewrite it as a matrix equation. Notice here that we have the matrix, the coefficient matrix, times the variable matrix equal to the solution or constant matrix. We'll enter into our graphing calculators into matrix A, the coefficient matrix, and into matrix B, the solution or constant matrix. Then, on our home screen of our calculator, we'll type in second matrix, and then enter to choose A. So on our home screen we should see matrix A. Then we'll press the inverse button. So now we'll see the inverse of matrix A on our screen. Hit the multiplication, and then we'll go second matrix and choose matrix B this time. Hit enter. So on our screen we should see the inverse of A times B. Then we'll hit enter. The result or solution is the ordered triplet 3, 2, -5.